All right, today we're going to tackle a classic science riddle. It seems super simple, but I promise you it has a twist that gets almost everybody. So get ready to see how your own intuition holds up.
So this is one of those classic questions, right? The kind where the most logical answer just feels correct. But, as you're about to find out, our world has some pretty powerful, kind of hidden forces at play.
Okay, here it is, the big question. Which is heavier, a kilogram of iron or a kilogram of cotton? Now take a second, really think about it. The answer seems obvious, doesn't it? I mean, they're both 1 kilogram. They should weigh exactly the same. Case closed.
But what if I told you that obvious answer is actually wrong? Yeah, we are about to totally flip that common sense assumption on its head and uncover this super fascinating piece of physics that, believe it or not, affects us every single day, and we don't even notice.
That's right. Under normal, everyday conditions, the idea that they weigh the same is just incorrect. So the real question becomes, what on earth is actually going on here?
So check this out. If you were to put both of them on a super sensitive scale, right here, right now, the kilogram of iron would actually show up as being heavier than the kilogram of cotton. I know it sounds completely impossible, right? But this is where the clues to solving this whole mystery really start.
Okay, so here's our first huge clue. Now their mass is identical. 1 kilogram is 1 kilogram, no doubt about that. But look at their volume. It's completely different. You've got this tiny, dense block of iron on one hand and this massive, fluffy pile of cotton on the other. And that difference, the amount of space they take up, that is the absolute key.
So, you might be asking, what does volume have to do with weight? Well, that brings us to the hidden culprit in this whole mystery, the air. The air all around us. We almost never notice it, but we are literally living at the bottom of an invisible ocean.
Yeah, it's not just empty space, It's a fluid. And just like water in an ocean, the air we live in pushes on everything inside of it. It exerts pressure. It's this force that we almost never think about, but it's always, always there.
And this upward push from a fluid, it has a name. It's called the buoyant force. You've definitely felt this before. Have you ever tried to push a beach ball underwater at the pool? The water pushes back up, right? Well, guess what? Air does the exact same thing. It's just on a much, much smaller scale.
This whole phenomenon is explained by a really famous scientific law, Archimedes' principle. Now, it sounds complicated, but the gist is this. The buoyant force on an object is equal to the weight of the fluid it pushes out of the way. Or, to put it even more simply, the more space an object takes up, the more of a lift it gets from the air.
And this is where it all clicks into place for our big pile of cotton. Because it has such a massive volume, it's pushing a ton of air out of the way. And all that displaced air gives it a pretty significant upward lift, that buoyant force we were talking about. It's basically helping to hold the cotton up, which makes it appear lighter on a scale.
So this brings us to a really important distinction. What a scale actually measures isn't an object's true weight. No, it measures its apparent weight. And the apparent weight is pretty simple. It's just the true weight minus whatever lift it's getting from the buoyant force of the air.
Let's just break this down. Let's look at the forces here. Both of them, their true weight is 1 kilogram. We know that. But the big fluffy cotton, it gets a pretty large buoyant force, a big lift from the air. The small dense iron, though, it only gets a teeny tiny lift. So what's the result? The cotton's apparent weight ends up being less than 1 kilogram, while the iron's is pretty much exactly 1 kilogram. And that's why it's heavier on the scale.
Okay, so how can we prove this beyond a shadow of a doubt? We've got to get rid of the air. We need to take away the cotton's hidden helper, that buoyant force. And the only way to do that is to put both of them in a vacuum.
So let's just think this through for a second. If the air is what's providing that lift, making the cotton seem lighter, what do you think's going to happen at the scales when we suck all that air out of the room? And here's what happens. In a vacuum, with no air, there's no lift. The buoyant force on both objects drops completely to zero. And what happens to the cotton? Its apparent weight goes up and up until it perfectly matches the iron's. All of a sudden, they weigh exactly the same. And that, right there, is the definitive answer. This whole riddle is just a trick of the environment. Without the air getting in the way, a kilogram is a kilogram. Their true, identical weights are finally revealed. They are, in fact, exactly the same.
So the next time somebody asks you this riddle, you'll know the whole story. And it kind of leaves us with a really fascinating thought to chew on. If the air all around us can create such a convincing illusion, What other invisible forces are out there, constantly shaping the reality we perceive every single day?